thank you all for coming. My name is Jordan Hine, and I'm sure you're all wondering why I asked you here today. Well, before I answer that, I have a few questions for you. Do you know how the universe was made?
God created the universe.
Sorry, I'm late.
Do you know what the universe is made of?
I believe it's mostly made of hydrogen.
Okay. Do you think time travel is possible?
Yes, they do.
How about you? Do you think that humans will ever travel at the speed of light?
Yes, I do.
Well, I have no idea. But scientists around the world are currently working on trying to answer those very same questions. Today, we're going to talk about Hadron Colliders and what they actually do. I'm going to be using the Large Hadron Collider seen here in the screen as my model, and I'm going to be explaining the 5-stage process it goes through. After that, I will be concluding my presentation. We're going to review some of the main points, throw in a little closing thoughts, and hopefully be able to have time to answer a few questions, if any. What do you think the Hadron Collider does?
Isn't it like that glowing thing in the back of the DeLorean that makes time travel possible?
Not quite. How about you?
Is it that thing in Spider-Man 2 that Dr. Octopus was trying to make energy with?
No, not exactly. How about you?
I believe it's a machine that creates a small version of the Big Bang.
Very good. Hadron Colliders are designed to recreate and examine conditions present at the birth of the universe. The Large Hadron Collider, for the Large Hadron Collider, this is a 5-stage process. The LHC is located between the borders of France and Switzerland, and it is housed on the largest physics research laboratory in the world, also known as CERN. Stage 1, compressed hydrogen gas is injected into a chamber. Then it's stripped of its electrons, leaving only positively charged neutrons. Next, an electric pulse is added, sending the protons on their first stage of the acceleration process. Stage 2, the protons are introduced into the booster. They will be separated into 4 circular tubes. An electric pulse is added, in addition to powerful electromagnets, which bend the protons around the circle. This is similar to pushing a child on a merry-go-round. In this stage, the protons will be traveling at 91.6% the speed of light. Last, they will be recombined and sent into the next stage. Stage 3 is called the Proton Synchrotron. In the Proton Synchrotron, energy is added, more energy, which increases the proton speed to 99.9% the speed of light. Now, it's not theoretically possible to go any faster than the speed of light. So, the protons increase in mass. And by the time they leave the synchrotron, they're 25 times heavier than they were when at rest. Next, the protons are going to enter into stage 4. This is called the super proton synchrotron.
say a little bit about this victim?
Stage 4, the super proton synchrotron. This is designed to accept these high energy protons. It also further increases their energy, which preps them for the final stage. Stage 5 is the LHC's main section, which is 16 miles in circumference. This section of the LHC contains 2 vacuum pipes. The protons are injected into the vacuum pipes in contra-rotating directions. Some of them will be going clockwise and some of them will be going counterclockwise. Sections of the pipes cross each other. This is where detectors are placed. Detectors capture images of the protons colliding. Later, that data will be analyzed by computers. Protons are now going so fast that they circulate the entire 16-mile circumference of the main section, 11,000 times per second. To safely house this amount of energy, the LHC has to be kept cold. This is done by using 130 tons of liquid helium, making it colder than temperatures found in deep space. This, in turn, makes the magnets become superconducting, and they produce a magnetic field that is 200,000 times greater than the Earth's magnetic field. The energy produced is equal to that which was present moments after the universe was created. Computers linked to the detectors analyze the data from the collisions, which gives scientists insight into the origins of the universe. So today we learned about Hadron Colliders, what they actually do. They accelerate particles near to the speed of light, they smash them together, then they examine the debris and the data. Gives the scientists insight, a little more insight into how the universe was created. Now, whether you believe in creation or the Big Bang, or if you believe that aliens are running the show, the fact remains that the universe has a past, a present, and a future, and humankind are at the threshold of some unimaginable discoveries. Let me leave you with one final thought. The imagination is limitless. What we think not possible today will perhaps be possible tomorrow. Thank you for your time. Does anybody have any questions?